should be live now. Starting in 4 minutes. Hi everyone. So today is a little bit different because we are not solving project order problems, but instead are joined with evalparse and solving HackerRank problems today.
Yeah, hi.
All right. So yeah, I started a new folder here. Started a challenge just before that to try out HackerRank. But yeah, do you have any challenges you want to do, evalparse?
Well, I thought what we might do is just go to the page and just choose an easy question to start with, and then to warm up, and then we work out what to do after that. I'm thinking about tackling like a medium challenge. Anyway,
Okay.
What is your stream? I can't find your stream.
It's also in the streaming channel on Slack.
All right. Okay. Awesome. I'll just make sure I can see the stream so I know what's going on. Okay. All right. Let's go choose a problem.
Yeah, so you have solved some of them already, right? So let's not do that.
So let me find because I have solved quite a bit of them. Let me try to find one that's meant to be easy. Any like preferences? Like I'm looking at the interview prep questions. There's greedy algorithm, search, stack queues, whatever.
Just choose one. I'm not prepared for anything.
Okay, then let's go with some sort of like. I'm just clicking the next problem available to me, which is sorting. So, all right. So in sorting, I have found an easy problem. Bubble sort. That sounds a bit easy, but let me just. But the first thing I should check is whether it supports Julia. Okay, so let me. Oh, supports Julia. All right, I'm gonna paste it into the Discord or streaming. Where should I paste it? All right, I pasted into the Slack, so you should see a question pop up.
Okay. Yes. Okay. Consider the following version of. So that's just normal bubble sort, right? Given an array of integers, sort the array in ascending order using the bubble sort algorithm above. Unsorted, print the following 3 lines. Array is sorted in nums. Oops. Okay.
Okay. So we just have to say.
Already Julia here. Yeah. By the way, for the day of programmer challenge I tried, there was a problem with std in. Did they change something there, or is this correct?
You need to change all the capital to just a lowercase. So std in is sufficient, not
Like
the
this?
capital. Yeah, that's and the same with the line 11.
Oh yeah. Okay. And okay, then.
So it's kind of done the hard work a little bit. It's read the. So all I have to do is finish off this count swap function. All right.
Yeah. So basically, it's just we can copy this one first, right? Write it into Julia code, and
I guess so. I mean, it's like a direct translation.
No, but okay, yeah, maybe it's not. Oh, we should also start with 1, right? And n is not defined and stuff like that. Okay, maybe just write it from scratch. Where is it?
Well, we need to keep track of. It wants us to print out how many swaps are needed.
How do we have to return it? Oh, we have to print
You have to do a print line, and then when you print line, print exactly this string.
Okay.
Yeah.
Is that the actual version of bubble sort with n-1 here? Isn't it n-I normally?
n-1. Yeah, I guess you don't have to loop through the n because you're doing a swap. So just
normally it's n-I, right?
What is this actually doing? No. That's correct. That's correct. J is correct, I think.
So when... Oh, wait. Are they... Let me check.
No. That's correct. That's correct.
Found a bigger or J
no,
plus.
not n-I. Definitely n-1.
Oh yeah, I was in a different algorithm probably. Yeah, because here we have the J plus I. Okay, and then
yeah,
that should work, right?
Yeah, absolutely. So we need a counter to count how many times we've done the swaps. Yeah. So that's it.
And then
I think you're meant to. So how should we do this? So in the function, I think count swap should just do the print lines. Yeah. So there, just print the to the print line of that. Yeah. Yeah. First element there. Yeah. All right. That's a pretty easy warm up.
Should be correct, right?
Yeah. I think just.
Why did I call it Euler? I'm so into Euler problems.
Yeah. The best way is just copy this guy into the website and just run the test.
Oh yeah. Okay. Yeah. I wanted to.
You know what? Your I right? The loop, the for loop that goes I don't think you need to loop all the way to I to n. You need to loop all the way to I to
Oh, this one is.
Yeah, because I think
we can.
And also I think your J starts from I, not from 1. I think. Is it right? No.
So we bring the first elements all the way to the biggest element just gets to the last position, right? With this J loop.
Oh, it's swapping everything to the back.
Yeah.
Then what's the purpose of lie loop? What's the purpose of lie loop? You have to do it n times.
You have to
you got to do it n times to ensure that you have pushed everything to the back.
Yeah.
Okay, I see. Yeah. Okay, I got it. Yeah, I thought they were following a different algorithm, but okay, I see. Yep, that makes sense.
So this should work now, right?
Yeah. So
and then just run code.
Just submit code. Submit code.
Or,
I mean, we're pretty confident. Okay. So we just go. A run code will run it against the test cases.
Okay. Yeah, that looks good.
Yeah. So if you do submit code, then it's like. Yeah, I think we've done it. Success. So, what time to choose another challenge? So I'm kind of sick of this sorting. What should we do? Can we do something different? Maybe. I feel like doing something like along the lines of greedy algorithms.
Yeah.
All right. So let's choose a medium one now because we've done our warm up. Let's do the greedy.
It was a good warm up.
Yeah. Let's do
we tested streaming and communicating a little bit.
Yeah. Okay, we got this. So I pasted into Slack, and it's gonna be it's called a greedy florist. Okay, I'm probably gonna take some time to read it. Oh, actually, yes, they do have a Julia support, so that's good. All right, I'm gonna have a read of it. What's going on?
You will multiply the price of each flower by the number of that customers previously purchased the flower. What a weird system. What? I'm a little bit confused.
Yeah, I mean it's. What the hell is it trying to say?
Yeah. I'm actually like, is there a good explanation later? Like just reading the function description, maybe?
Okay, so I'm reading explanation number 0.
It should return the minimum cost to purchase all the flowers. An array of integers representing the original price of each flower. Oh, okay. So we are trying to minimize the cost, whereas the florist tries to maximize it, and we want to use our friends in a way that we don't pay extra as much as possible.
Right.
So we have length, wasn't it? Length, number of flowers 3, number of friends 3, and the prices, and there we would just sum it up, right? Because everybody just buys one flower. That makes sense. And here we have only 2 friends. So one buys probably one buys 6, then buys 2. The other one buys 2 and 5 or stuff like that.
So the friends have to buy all the flowers, basically.
Yeah. So the first person purchases 2 flowers in order of decreasing price. This means they buy the most expensive flower. 5. Oh yeah, because it's multiplied by. Okay. And then 2, which is 9 plus the other one buys 6. Okay. Okay. Do I understand the next one as well? So one buys 9, one buys 7 and 3, and the other one buys 5 and 1. By the number of that customer's reason plus 1. So that it does not depend on the price, right? Okay.
Okay, so yeah, seems to be. I mean, I think I get it. You just have to. So if one person has to buy 2 flowers,
then it tries to buy the more expensive one first.
And the cost basically is just the cost is basically just how many flowers he's purchased before plus 1 times the price. Yeah. So okay. So okay. I'm almost sure you have like an algorithm in mind.
Not really, actually. So we could. So for the first one, it's just check whether the number of flowers is the number of friends, and then it's easy. Or if it's like more than that, which is probably never the case.
Well, I mean, I don't think we need to check the length. So I think the principle is always that the most expensive. Say you have K friends, you should buy the K most expensive flower as your first purchase, because that way you don't have to multiply the price by anything. You just so that's the first K purchases should always be just buying the most expensive ones.
Oh yeah, that makes sense. Oh yeah. Oh yeah, it's a greedy algorithm, right? Oh yeah. I was just thinking about dynamic programming all the time, and I was like, why can't you just use greedy? But you shall use greedy. Okay. Now everything
I think
makes more
this
sense.
greedy algorithm also happens to be the best, because you cannot do any better than that. You have to buy all the flowers first. Okay, so that would get rid of the K. They would get rid of K flowers already.
Yeah. By the way, is the number of or the price is the price sorted?
Sorry?
Mention of it seems like in the sample inputs the prices are always sorted, but I'm not sure whether that's the case.
Well, I think sorting it wouldn't be that expensive. So
yeah, we should probably just sort it.
Yeah. because look at the constraints. The constraints are n and k both less than 100, so you have less than 100 flowers.
Yeah.
Okay, this is why I think the algorithm should just be like, get the most expensive K flowers, and then it doesn't just, I wouldn't just like repeat after that, like in a recursion way. Choose the most expensive flower and just continue.
So we have, so then in sample input 2, we would have 5, 7, and 9 already. And now we basically want to have the next batch, right?
Yeah.
Such that the one who, it doesn't really matter the order afterwards, right?
No, it does matter. Imagine
like,
you have even longer sequence.
Yeah, okay.
But the principle is the same. I think you just always buy the most expensive flower first with your, like, okay, so you get your K customers to buy one flower, then move to the next customer, buy one flower, then move to the next customer. So you only have to raise the multiple after K purchases.
Yeah. And I was thinking that it would be much harder, or it would be harder if the costs would also depend on what he bought first, but it only depends on how many things he bought. So the order is quite irrelevant.
Yeah, that's right.
So if we have, for example, let's say 3 friends, and we have 1, 3, 5, 7, 9, stuff like that. We would buy these one first,
Yeah,
then these one second, and these one third, right?
Correct.
Okay.
So I think we just have to increment our the flower price multiple, increase it by 1 every K times, every K purchases.
Yeah.
Yeah. So that's it. I think a double loop would do it.
So basically, the first one would be kind of that.
Yeah.
Oh, we should be, I don't know. We should probably be aware that this might fail at some point.
Isn't it n to the K minus K all the way till 1? Oh, it doesn't work. No, it doesn't work like that. No.
Okay, maybe start with cost of 0, and then we can. Is it easier if
I'm just thinking we should just do like a for loop. So like I'm thinking if you do for yeah.
Yeah, I was thinking about whether it's easier if we actually sort it in reverse and just keep track of by how much we have to multiply it at the moment. If you know what I mean.
Exactly. Yeah. So I think sorted in reverse, that will make the code easier.
What is it?
I think it's ref equals to true.
Ref. Yeah. And then I don't know, currents.
Okay, so I think we should use the cycle thing. So I think it's like for C and I in zip of C and cycle 1 to 3.
Oh, can you repeat that?
For brackets I, comma C, or if you want, you can try the live extension I and C in zip of in zip of I think if we write like iterator dot cycle 1:3. 1:k, I think should be 1:k. Yeah.
Oh yeah, yeah.
1:k, and then after the cycle, do a comma, and then do the C. Not Z, C. Yeah, C.
Yeah, but here it should be like, I don't know.
Yeah, it's only
Be
different.
something else, right?
Well, it doesn't have to because you don't refer to the big C inside. But it's fine. It's okay. Like this, I think this would work, right? No, why am I cycling through K? That can't be right. No, I got it wrong. I think it's I think you have to I think forget about the zip. Just keep a counter like cost multiplier or something.
I'm a bit confused of what you're trying to do right now.
Do you have like live extensions? If you do live extensions, then I can edit the code like directly from there.
Oh.
Just install the live extensions, and you can remove it afterwards. Probably. I think it's called live share. Yeah, live share.
Oh yeah, that one.
Yeah. Then I think you just give me a link to it, and then I can edit it directly.
Yeah. Oh, it's already there.
Yeah. Oh, you got to sign in. Yeah, it's annoying.
I hope it's the right one in Slack.
Okay.
I hope it's not read only.
Oh. Okay, I'm in. So you should be able to see me now on the cursor.
Yeah.
Okay, so what I was on about was okay. So I'm sorry. I think I needed to get rid of this. That's what I'm saying. I think that's sufficient. Actually, maybe that would be good. Like that. And then if modulo I of k 0, that's what I'm saying. Multiplier plus or equal to 1, like that.
Yeah. Okay.
I think your the cost plus equal to smaller. Yeah, that's collaboration.
Oh, we should.
Times
you
it
put
by.
the, okay.
Is it where's the C? C cost? Yeah. Okay. No. So you can't call this cost. We can call it C. That's fine. It's a bit confusing, but I think most people get it.
Oh yeah.
And then you return the cost. Yeah, that's right.
Yeah.
that looks like it. Yeah. It looks fine to me. Try that. not defined.
Oh. I don't know how I called it. That is way too high. Oh yeah, we don't need that one. Enumerate this index value first. Okay. So because starting with 1.
I think we should move this to the bottom.
Oh yeah, makes sense. What?
Demons, no.
I'm confused now. Line 15. Is this? Oh, did you change something there? Oh, I copied it, right? I think it should be like
doesn't
this.
it commas in between? Or I don't think.
Yeah, I think I just copied it over.
Yeah. I mean, I thought it would work as well, but I don't know.
Yeah, I thought it
Is it
would work
working?
as well. But that seems correct. Do we?
All right. Yeah, one thing about HackerRank is their classification of the problems are not always correct. So submit code. I think sometimes their medium problems are actually a bit too easy.
Oh, is it a medium one?
Yeah, it's meant to be.
Oh, okay.
Yeah, I guess we should try another one.
Whatever that means.
Yeah, you got one. I also don't know what that means. Maybe we should try something a bit more crazy, like how about string manipulation?
We are 2 programmers. We can do double.
Double. Yeah, some of them are two. Some of them are quite easy. So I got this common child one, which is only meant to be only 53% of people can solve. Maybe that's not hard enough. It's meant to be a medium difficulty question, So I don't know. Yep, also supports Julia.
Oh, what happened here?
What do you think about those two problems? A bit on the easy side, you reckon?
Yeah,
it's a bit easy.
The Project Euler ones are like some of them are at least harder. There's some really easy ones, but I think some of them are only easy for Julia, like big int and stuff like that.
Yeah. Common child. I think it is common child is also a bit too easy.
Is it? Okay.
I don't know. If it's too easy, we should go to the HackerRank Project Euler. Did you know HackerRank includes Project Euler problems?
I just saw it right before the stream.
Yeah, but it's different. All right, so let's look. I'm gonna have a read of the question. I don't know anything about it.
Oh, okay. Can't rearrange. Okay. right. Did you read the question already?
I am reading it still.
Okay.
I mean, happy to go ahead.
Well, this time we have to put some of our own code here, like reading it and stuff like that.
It's actually not that bad. I think you just have to do read line twice from the std in, then you get your inputs.
Okay, yeah. I'm just a little bit lazy. And we just have to. So do we normally have to output it like with print line, or how does it work?
Yeah, you output with print line.
Okay. Because here we somehow wrote it to a file.
It doesn't write to a file, it writes to send it out, I think.
Oh, yeah. So, I don't know. I hope that's kind of sufficient.
We're trying to find the most common child. And I think all the inputs are uppercase.
Oh, okay, yeah. So this should be sufficient for reading it, right?
No, I think you need to do read line twice. Because the first read line returns only one string, and the second read line, you don't need to split anymore. Just go A equals to read line, B equals to read line. That's
okay. I see. Yeah, makes sense.
Yeah.
All
right. Common child. We're meant to return the longest common child. Okay, how do I do this?
So, okay, and they have the same the same lengths, and they have to be in the correct order.
Yeah. I'll quickly go to the bathroom. We'll be back soon.
Yeah. Yeah. So I'm currently thinking about that we can just remove characters which don't appear at those strings. I'm not sure whether that helps a lot. You're back?
Yeah, I'm back.
So I was thinking about we can always operate from just one of the two, right? So,
Okay.
for example, if we have Harry and Sally, we could start with, let's try with H.
Yeah.
And then we can't find H. So we try with A, we find A. And then try to find the next letter which matches and so on.
Yeah.
Does that make sense?
Yeah. The issue is, say you match one letter, but then subsequently there's two letters that could match, and one is longer than the other.
Can you give an example of what you mean?
So actually, no, that's not right. So yeah. So they match A, and they match BC. Say BC. So ABC is one. But the longest one is actually A. So AB and A triple D are both subchilds. But
so the longest one would be A, B, D, 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 right? The
yeah.
So I was thinking that we start with A, check whether it exists, and then add it to the. But I'm not sure whether mine is recursive.
Okay, I think I'm thinking more something along the lines of this. So A, B, and A triple D are actually not triple D, but let's make it triple D. So the longest one is A triple D, right?
Yeah.
So it's the algorithm needs to be able to find that instead of finding AB.
Yeah, I would then basically continue with the approach so that I have, if I found AB, I check whether there are longer ones than AB.
Right, yeah.
By just going to the next. But I'm not sure whether that's reasonable.
Let's check the input length. The input lengths are less than 5,000. So both strings are less than 5,000 characters. So because I was thinking I would do this using like a recursive method and then just recurse. But I don't know if that's gonna do it for 5,000.
Yeah, I'm not too sure either. But okay, they are all strings, right?
Yeah.
Okay. Does it help if they? Oh no. I was just thinking that we only have 26 different characters, but this does not help in any way, I suppose. Okay. We do.
Oh man, this is quite hard. Let me have a think about it. And while I think about it, I need to make some food for the dogs, and then it'll take me a couple of minutes. I have to
Okay,
silently
yeah.
think about this.
I will think about it too. What do we have to output the number?
Come here. Sunny. Sunny. Eat.
Okay, but we need to not return. We have to continue. I don't know. I'm just thinking about the recursive one, how to write this in a reasonable way. Because we need to track the maximum length.
Yeah.
And also every time call, which is, I'm not too sure. So
you have to return the output is just the maximum length. Okay,
yeah,
you don't even have to do anything. You have to keep track of it. Okay, cool.
Oh, okay. That's
okay.
We have to set the maximum length somewhere, of course. Yeah, I'm not too sure how we define the what do I actually need len? Do we need that? Yeah.
Your L, shouldn't that be like what's length equals to length plus 1?
So I
Where's
want to
length
increase the length by 1. But we need to keep track that this also includes
but this length is not used anywhere.
Yeah.
I think you're thinking something like that, right?
Yeah. Something in that range.
So if it finds one character that's matching.
Yeah, I was thinking that it always makes sense to take the first one that's matching, right?
Yeah. I mean, you cannot find a second one that's matching and somehow end up with a longer one.
Yeah.
So you must, I mean, either way, you have to find something.
So okay,
if something matches, then wouldn't my
what is this weird stuff? Okay, so basically, let's start with Harry and Sally.
So you increase.
Don't find the H. We try the A. We found the A. Then we call it with RRY.
Shouldn't you do it here as well? And do it again here?
Oh, yeah, okay. Maybe.
Because the first time you do it, you already found something of length. Yeah.
Okay, yeah, so this is what we expected. And then it doesn't found RR, doesn't for LNL, found the Y, and then just because it's the last, it returns with S1 and S2 is nothing. Currently not sure why it does it twice.
What if you run the test case, the Harry and Sally? What will return now?
It returns 2 now. You can see the my terminal, right? Or can't you? With like.
Okay, yeah, I can see it. Yeah.
Okay.
We'll just put the next test case here.
And 880. Yeah, okay. That makes sense now.
Is it working?
Our your ADD test case worked.
Okay.
And for the other one, it's 3, which is also correct.
Well, let's have a try. Can't be.
But we need
Well,
to.
I think you need to get rid of your print line statement because it's gonna.
And we need to basically print common child, right?
I think you should, yeah, just set the result to the result of the common child and print it once.
Let me.
Oops. Find first. Oh.
What kind of Julia version do they run?
Maybe 1.2, I think.
Oh, it needs 1.3.
Yeah.
But can we convert that to? We can do something like this, right?
String C. I don't think. Actually, no. You don't actually have to do that. I think this is sufficient.
Oh yeah, that might also work easier. Is it safe? No, that doesn't. Oh, I think it's.
I think find first doesn't exist.
Oh.
I think you want something like this.
Yeah, we need something like, I don't know.
Yeah. Actually, I show you this. I show you this. Try that.
Oh, yeah, I saw that somewhere.
Yeah.
Yeah. Okay. And that's.
Hopefully, or maybe find first. The function doesn't exist. You have to do find.
Yeah, but I think so. Only the char one didn't. I think only this one, the abstract char in abstract string, does not work in.
Okay.
Yeah, because here find first, it uses function any, which should be the one we are using.
Okay. Cool. Wrong answer.
Did I copy everything?
Yeah, I think you need to comment out the print line. Yeah, comment that out.
Yeah, okay.
Well, looks correct. Yeah, we haven't encountered that. Sometimes it says your algorithm is too slow, so it doesn't pass all the tests. What's happened?
We failed.
9,
10, and 11.
Well, look at the error code because I'm on a little bit of a lag to see if it's saying that it's failed the test case or failed by time. If it's timeout, then we need to find a slightly more optimized algorithm.
Your code did not execute within the time limits.
But is it for all of them? Or the ones that failed?
Looks like. We failed quite a lot.
Okay. Maybe we can improve this. That's why HackerRank is hard because, yeah, you need to make it really efficient.
Yeah. Yeah, one thing is that we always create new strings, which is quite inefficient, I think.
Yeah.
So we could just save the position as well. So have like P1 and P2 and just start from there.
Yeah.
That makes sense.
Yeah.
And now basically something like that. That did not work. Did we use somewhere else? Oh, because we have in here in S2, we need to have something like that.
Yeah.
But I'm not sure whether that's really faster.
Well, can only try.
I think this collect is still bad. Can we see how many we failed easily?
Maybe if you enlarge the browser to the full, then you'll get it listed. I think you see a list, right? So I think
we failed 2, 3, 4, 5. Okay, we actually, let's just. Oh, did I change it? Yeah, I changed it. Oh, now we're failing 0.
yeah, that's not good. C equals to SI1.
Now we have wrong answer at some points. I think test case. Oh no, that's. Oh, 11 of 15 was.
Oh, what? That's a lot.
Still why do we have the wrong answer at some of them? No. What did we change? Like, really?
I'm pasting the our code into my one as well, so I can check.
Yeah. Go for it.
I think, yeah, okay, it's passing some, it's failing a bunch of them.
Yeah, and it passes all
Wrong answer.
the first one.
Have we dealt with the case where well, we haven't initialized? Oh no, we have. Okay. What about this test case? Does it work?
I think it does.
Okay.
That one still works.
Okay, that's working. I mean, they can't give us a empty string, so because the string have to be at least length 1.
And even that will work, right? It would just return 0.
Yeah.
I'm just wondering, I think we passed some more tests before the change, right? So, but I can't see what we changed wrongly.
Good point. It doesn't do anything. Length of
But it's
S1.
more readable, so I
Oh
assume
no, we can't do length of S1. We need the length of the original. With the length of the original. Oh no, actually, that is the original one because then it never gets shortened.
Yeah.
Okay, P1. Okay, that's still correct.
Oh, I think this should be P2 plus or stuff like that.
Yeah. Otherwise, the offset is not correct anymore. Yeah.
Yeah. I'm not sure whether it's P2 minus 1 plus. I think it's this, but I'm not too sure.
So if you say the first time you found the letter in the third position, POS would be 3. And then you would need 1 minus 1 plus 3 plus 1. Yeah, starts at 4. So that's correct. Minus 1 is correct.
This.
Yeah, 1 plus 3. Yeah. That looks correct because if P2 is 1, then position is 3, then you need to start at 4.
Yeah. Give it another go. Okay, test case 0 is solved, which wasn't solved before.
Okay, that explains it.
But it's still taking time. Yeah, test case 2 still fails, which failed before. I think it didn't really get faster.
Yeah, I think the situation is this. You see my last test case? It's doubling up all the work that's been done.
Yeah, the one I'm testing was just repeating 10 takes a long time.
Yeah.
So your test case.
Well, the idea is it looks for A and then finds A and then it goes from B to D. It doesn't find B, and for D it builds up the whole thing, and then it starts at B again and builds up B. But you see, when it starts matching on D, that's just work that's been completed before.
So
see,
we are starting with.
So if you look at the top case A, once it finds A, basically to match D, it's some amount of work. And then when you start looking at the second letter, you'll find B. B doesn't match anything, but then you'll find that these match, all of them match. But we already know that the D match after looking at the first iteration. So when I'm looking through the letter with A in mind, I already figured that out. So I don't need to do that again. So almost like we have to reverse the algorithm and build it up from the other side. You know,
I'm still not getting what you mean by we do something twice, because we only loop. We always decrease the number of.
Yeah, but it's decreased twice, right?
Oh. I think we are actually doing it differently than I thought we would.
I think we have to build up a library of things, actually not going this way, but sort of almost from the back. So for example, if I go, okay, what's the best I can match with D? Okay, well, yeah, we got match D. What's the best I can match with DD? Okay, DD. What's the best I can match with DDD? Oh, I can match with DDD. So you just end up building the best matches, starting from one letter and then two letter, but coming from the back. So that by the time you reach B, you go, okay, well, what's my best match? Well, my best match is still the DDD because I can't improve the opponent anymore. So by the time you only end up doing the work once instead of multiple times.
Okay. Yeah, maybe you can start.
So
maybe
say
just create a new function. Yeah, and
okay, so
I'm thinking about it again. It's more complicated than I expected.
I think my idea would boil down to building a dictionary. Okay.
Is the key from where to where, and or what is key value?
Yeah. So what I'm saying is, I just have to put the P1 and P2 into my dictionary, my starting points. If it's already figured out that from P1 and P2 that's the best, then yeah, just
okay, yeah,
because that would then I don't have to compute it again.
Yeah.
Right. And at the end I say dict of P1 P2 equals to max length. Yeah. So basically, we just memorize the function. Basically, that would speed
but
things
you
up.
don't want to have. You want to have the dict as an input, right? Or like outside the function.
Yeah. You're right. So the dict should go at the end, maybe. Yeah.
I think you can also just put it outside the function and have it const, and then just put over like a global variable for our test case.
I don't want a global though. It should be specific to the S1, S2.
Oh, okay, yeah, okay.
I mean, I don't see why this shouldn't work, because once you figure one thing out, you don't need to compute it again.
Yeah.
Okay, why don't we try this one then? I don't think there's anything more I need to do. Common child 2. Of course, there is. I need to call that common child 2 as well. So let me try it on my one. Let's see if I can pass.
It has length 7.
Runtime error. Common child not defined. Yeah, okay. What's wrong with it? Anything wrong? No.
No, the first one looks good.
Oh, it's passing. It's passing all the easy test cases. It's still failing. Yeah. Still not fast enough. It's still
not
failing.
Fast enough?
I'm not sure. It's failing test case 1.
Okay.
Oh, wrong answer.
Yeah. Test case 1 is solved by the other one.
What am I doing? Oh, no. I am correct. No. L equals to that maximum.
Because you always solve.
Why am I getting the wrong answers now? No, I'm looking up the wrong things.
Oh, there it should be I plus.
Yeah, it should be
I plus
1
and P2 plus.
Okay. Yeah, I'm looking up the wrong things. Yeah. Okay. Like that. Right. If it already knows.
Okay. At least one thing changed, but for that one, I don't know the real answer. But for example, if you have a look at the repeat one, right?
Yeah.
There, for one of them, or for these two together, it should be 3, I think. Yeah. So then it should be 30, right? But for us, it's 27.
Missing 1.
If I'm thinking correctly. Does that make sense?
Yeah, so if one of them is 3, 10 of them should be at least 30.
Yeah.
Yeah. I think it's simpler than that. I think it should be
By the way, this okay, doesn't throw an arrow, so it should be fine. It's interesting. But there you still have to check the max length,
Hey.
right? Shouldn't this still be okay?
I'm thinking through.
So I think in line 18 it should be max of max length and yeah. Does that make sense? Okay, now it's taking a long time to compute it again. So probably not what we are.
Shouldn't that be?
Oh.
No, that can't be right. That can't be right
No.
because now it depends. Introduce a dependency on length.
Yeah.
It shouldn't have a dependency on length.
But yeah, I think that's a good point, that it depends on what we have done before, or does it? No. I'm not entirely sure about that. So basically, yeah, it shouldn't have a dependence on the length, right?
Yeah.
Just
I should be able to say I'm comparing the ith substring with the second substring starting from P2. What is the length from that? Right?
so basically your dict just saves given at what point we are on, what's the maximum length from that point,
from that
right?
point on, yeah.
And but does that actually help? Oh, because we are.
I think. Okay, I actually don't know if building a dictionary is a good idea, but it sounds like it's a good idea. But I think I also want to remove all of these dependencies. I have a feeling I shouldn't have to rely on this to figure out what's going on.
I have the feeling we're making it more complicated than it is.
Yeah. So, I mean, to me, that's the trick that usually works, right? Just by keeping track of things that we don't have to compute again.
Yeah. Okay.
I'm just going back to my example because if you maybe look at that one. In your first loop, when you're looking at the letter A, you would have match A. Once you match A, you try to match B, D, D with D, 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 right?
Well, I would check if B exists, which it doesn't, then check D, find the first D, and so on. But I will also check later on D again against, which is stupid.
So if we just keep track of from here and from here, they're the same, then you get the best of both worlds already.
So like is a very simple one would be when we have the first common child, like common child first solution at the top, and we don't if we encountered the character before, then we just continue because it doesn't get better anyway. So basically the find first also for S1, if that makes sense.
It doesn't work because your P2 also changes. So if your P2 is different, you might find a different position.
No, I mean in the same P2.
Yeah.
So for example, if we have something like this.
Yeah, for the same P2, then you don't have to. So therefore,
then we only need to check the first A, right?
Yeah.
Oh no, we don't have to. We also need to check the next A if it has another match. But if it... No, it's... No, that's... doesn't make sense. Because if it has another A in there, we have to...
What if we keep a dictionary of the letter you're looking at and the P2? Because that will always return the same thing.
Yeah. I think so. So that's basically the idea I just mentioned, right? But
Yeah.
using the dictionary too. Okay, yeah.
How come there's two functions now, one common child first?
I just wanted to have the one we are working on called common child and not common child 2.
I don't think we need to keep track of the length equal to 0. I think we just have to keep track of the max length.
No, it's just because we have to increase the length by 1 all the time. But yeah, I'm still thinking about
yeah, to increase the length by 1. Sorry, keep going.
What you had here before.
Yeah.
With the max length, because it actually depends on the current length we have, right?
Yeah.
So with
that's why it's not correct. So I think.
Yeah, I think we need that len plus.
No. So instead of doing that, all you have to do is just do this 1 plus. So make it not dependent on length. Because if you figure out there's a match, all you have to do is do the rest as if you're starting from 0 again, correct?
Oh, okay.
So you don't have to keep track of a length. So that will get rid of one dependency.
Okay, yeah.
Yeah, so therefore I don't even need to keep track of the max length as well, I don't think. Do I have to? No.
I think we still need max length.
Oh yeah, we probably but the max length, I don't think I need to keep track of it forever. I just need to keep track of the max length at the same level. Yeah?
Yes.
Because because yeah, if I'm looping through all my letters, yeah, I have a feeling that I don't need to keep track of it at this level. I need to just keep track of it at the loop level.
Yeah, I think
okay, so therefore I can just put that as my L. So after I sign the dictionary, I go if length bigger than max length equals to L. And at the end, I return max length. So
should this be outside the else for this one?
Every yeah, because every letter that I do okay, so starting from letter I, if I have P2 to deal with in the second string, yeah, so I and P2 completely determines the state I'm looking at. So I should be able to return the right things. And then if I don't have the results stored already, compute it from scratch. In which case, if there's a match, I add 1 to it. If there's no match, then
we just continue. in new and return. Yeah,
I mean,
the
this
max
is.
length max.
I mean, this is just a bit slow, but it's not that big a deal. If there's no match,
then we have nothing to do, right, with changing the L. Or the max length.
Yeah. Okay. Can we try it? Can we try this on our test case? I'm going to copy it into my test case. Test it.
Oh yeah, we have the 30 now, which looks good. And the other one is the same as before. Oh.
Okay. Yeah, I mean, it's, you know what? I'm just going to chance it. I think there's still some optimization to be made, but I reckon we can try submit code.
Running.
The optimization I'm thinking about is what if I don't find a match? But that should already be taken care of as well, right? Because if I don't find a match, then yeah.
Yeah, then it. Okay, we have at least one failing.
So I think I will check if the failing is due to time or due to wrong answer. If it's wrong answer, then back to the drawing board. But if it's time, then we might have a case. We might be onto something.
But I think we're solving more than before.
No, we're just returning max length.
No, I mean we are solving more test cases.
Oh yeah, better than before. Okay, yeah, that's good.
So. But
I suspect it's that optimization we have to do for the case where we don't do very well.
It's taking quite some time.
Oh. All right. Okay, I'm suspecting that if we don't find anything,
terminated due to timeouts.
how many are due to timeout? Do you know? I can count.
1, 2, 3, 7.
Yeah. Okay. So
15, right?
15. Yeah, 15. Okay. So I think this algorithm is correct. I think we just have to optimize the part when we don't find anything.
Okay. Yeah. Let me. I want to do some benchmarking on one of them because I think the collect is also like maybe it's not the best idea to actually use find first with collect because we always copy it.
Yeah. Should we code our own find first?
Yeah, you can just Oh, but we,
That's fine.
yeah.
Make a types table.
Oh yeah, but we normally have.
Hey.
Okay, so you want to have this?
So if I don't find anything, I return I return 0.
Oh, okay, yeah.
Just to make a types table.
But you want to have an. Oh yeah.
Yeah, just put length of whatever.
That's what you have, right?
Yeah.
You return 0, no?
Yeah. I mean, that's one optimization, but I think just imagine a string where there's a long stretch where you don't have anything matching, right?
Oh, but now you actually return. Now we don't need this one, right? This P2 plus pos. It's actually P2 now. It's actually pos now, right?
Yes.
But it produces the wrong result.
Produces the wrong.
Or
Pos plus 1. Pos plus 1. Because you need to look one pass. Yeah.
Yeah. Okay. Makes sense. Let me check whether that's changed actually something. Yeah, it got faster.
Hey.
From 8 milliseconds to 5, and from 7 megabits to 193 kilobits.
Okay, I'm not sure that's fast enough, but worth a try on the platform.
Yeah.
I'm thinking how to speed up the branch where it doesn't find anything. Because if you have a long stretch, that's going to be painful. That's going to slow down because it keeps on doing the same thing over and over again in every. Oh, actually, it shouldn't. It should only do it once. Oh, no. Actually, it'll do it. It'll do it over and over again.
Oh.
Hey. Find first.
Oh, yeah. Much better.
Hey, we've done it. I think, hopefully. I don't know.
Nope.
But
it seems like we have wrong result, right?
Wrong result?
Oh, no.
Okay.
No, time limits.
Time limit. So, but let's case it with time limits, right?
2, 3, 4, 5. Still 7, but I thought we haven't solved test case 2 before. That was weird.
Oh.
Okay, it's still 7. Seems like. Okay. So
I think we should do it like this. If you can't find anything, then we go dictionary I of P2 equals to -1. So it's no longer, I no longer have to scan through this. It's just the cost of a dictionary lookup. So if dictionary I P2 equals to -1, continue. So I skip a bunch of lookups.
Okay, because yeah, I don't think you need this especially, because it just checks whether -1 is bigger than anything.
Yeah, I see what you mean. Yeah. I mean, we can try to do without it. I don't know which one is faster, honestly. Actually, yeah, without checking is faster because you save the lookup on the dictionary. Because comparison must be cheaper than looking up from a dictionary. Okay.
Yeah, there's no real change.
No real change?
Because yeah. Or maybe my test case was just not applicable to that one. I don't know. Because I'm not sure how often we go into the point where we don't find it, especially for long ones, where probably every character is kind of given. But yeah, I mean,
if I'm designing the test cases, I would make one just to trip people up. I would just
that's true.
reserve the letter Z.
We're still failing 7 of them, so
yeah. I mean, we can always spend points to buy the test case to see exactly what it is. Because the dictionary lookup, obviously, I can't think of any other way to make it faster, actually,
Yeah, I'm not too sure what actually takes the most time of the functions. Is it just that we call it a lot of times?
Yeah.
Probably.
Well, how about we let me just buy one of the test cases, okay?
All right.
Actually, one thought just occurred to me. Why don't we do a one-off conversion of the strings to a vector? Then because string access is expensive, right? So we do a one-off conversion. Just do a collect once. The algorithm is actually exactly the same.
Oh yeah, that makes sense. Yeah, I was thinking about that as well, because we have we don't have Unicode and stuff like that.
Yeah, just do a collect once, and we should be the algorithm just the same due to the multiple dispatch. We probably can go back to using the proper find first function. We don't have to use this one anymore. So in here, just collect. So okay. So so this is the place where you want to do a collect?
Yeah.
All right, collect on that. Collect on that. And the rest of the I'm going to change this find first back to the original one, right?
We could.
In fact, it might be better because now we can use a view.
Okay. Yeah, it's twice as fast.
Okay, that could be sufficient, But it doesn't return the position 0 anymore. We have to check for the nothingness.
Yeah.
Correct? All right. Oh. We're chipping away.
I think you still need this, right?
Yeah, that's right.
But it's wrong result.
Yeah, I think we have to go back to what we were doing before here, which is
there's
P2 plus P cos, like that.
Yeah. Okay. Yeah. That looks good. Okay.
Oh, frick.
Please, test case 4. Please, let's solve test case 4. Oh no, it's the same as before. I think there's something much better somehow. I think we have to start from scratch to find a better solution.
It is a little bit unfair against Julia because it's Julia the compilation times. I don't know how it deals with it. Okay, I want to check the top submission to see if anyone else using Julia has solved it. I want to filter by language. Yeah, I mean people have solved it using Julia.
Okay.
So it's possible. So I think our algorithm is just not fast enough.
Yeah. Oh. But we don't have, yeah. I was thinking about if we keep track of the maximum lengths, it might be possible to check, like if we already have a maximum length of 10 and we currently have a length of 2 and we only have 5 letters left, then we can't go over it. So we can break earlier.
Yeah, that's right. You mean something like this? If length S1 minus I less than max length. Right.
Yeah. I'm just wondering because at the beginning, our max length is always 0. And it's not actually length of S1, but length of S1 minus P1. Oh, minus I. Okay, yeah, no, makes sense.
Yeah, when it's 0, it doesn't do anything, right? It just
I mean, when I'm still a little bit confused of our usage of max length, I think. Yeah, it still got a bit faster, but not by too much for our test case. Maybe we do. What is the maximum length? 5,000, right?
5,000, yeah.
Yeah, so if we increase, if we multiply the length by 10, it got a lot worse, like 1,000.
Right. Yeah, why would it get so much slower? Yes.
Hmm. So I have like 30 minutes left, then I have to go.
Yeah.
I'm still thinking whether there is like a totally different solution.
I could be. I have some vague ideas about building up from the other direction. So we end up with smaller area to look at.
Hmm. Yeah.
Yeah, you see some problems, some medium problems are really hard. Some medium problems are like,
This is a medium one?
it's a medium one, yeah.
Yeah.
I think that classification is not 100% correct.
Is it the
Unless
one
we
which
missed
only
something.
half solved?
Yeah, I mean, it's HackerRank is tough like that because not only do your algorithm have to be correct, it has to be really efficient. And also, I don't know how they deal with the compilation of Julia. Maybe they just don't run a compilation.
Yeah, but ours shouldn't have much compilation time, right? Because we don't include any libraries and stuff like that.
Yeah.
I think it should be.
I get it. There's an optimization that we can do.
Tell me about it.
Okay, say we're looping through all the characters of the first letter, right?
Yeah.
Of the first string. So say you find that okay, the first match is in the 10th position of second string. Okay. So then you do the rest of your algorithm. You figure out the max length for letter 1. Okay. So now you move to letter 2. If letter 2 first match is more than 10, you can ignore it already. Because it must be smaller than the first one. I give you a test case, right? I give you a test case.
Yeah.
So you see my test case at the bottom?
Yeah.
Okay, so imagine I'm doing a loop, right? A, right? My A will find this A. Okay. So imagine if I keep track of the position of where I found A here. So once I've done the rest of the algorithm, I would have figured out that the maximum length of A is A, C, 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 right? I already figured that out. And now I look for B. B comes after A.
Oh, and therefore it's already worse.
Yeah, then wouldn't it be already worse?
Oh, it cannot be better.
Yeah, so I don't have to look any further. Is that right? Or am I missing something? I'm thinking something along those lines, you know?
Yeah, no, it makes sense because we don't look back at any point.
Yeah.
We always look forward.
I'm thinking if I miss something here.
So basically we can do the find first for all of them and then decide which one to choose. And then
Or
we only have...
Yeah, or just build up a library of the find first positions and then just ignore anything that's worse than before. Yeah.
Yeah. So then we only have one recursive call every time. So we basically have a loop.
Well, no, you don't. You have something like or maybe I'm misunderstanding you. I'm thinking something like this, you know, find first position, right? And this find first position would be actually.
So what I'm thinking about is that we keep track of the first position in S2 and the corresponding position in S1 for the C, and just choose the one where the position is the smallest. Does that make sense?
No.
So something like if pos. Oh, that should be like... And then we basically have this.
Smallest I.
Oh, is that not?
No, I don't. It doesn't.
Not work?
It seems like you might be skipping some digits.
Oh, because we...
Let me just copy that and go back to the thing, right? Go back to the previous one.
Yeah.
Don't worry, I made a copy of the code, so
Okay.
I'll just go back to the. Oh, what's happened? Oh, it's fine. So that's let's keep this here commented, right? I think this one will skip over some things. I'm actually thinking something along the lines of this. So I go the find first position. So I keep a list of, for each of the values, what is their find first position, which is like, you know, yeah. So I go, oh, just zeros, int, and then for now I make it a bit, it's probably not efficient, but it's only 5,000 maximum, so it's not that big a deal. So like, this, the whole purpose of this array is to keep track of where I find things. So it comes down here, it goes, okay, then I go set the position, because I know what it is, of C is equal to, yeah, okay. So I set it, and I go, if this guy is after the previous guy, not just after the previous guy, but is after is after the minimum of the previous guys, then forget it. You know, don't need to look.
Yeah, but isn't that exactly what I do?
Is it?
Because why do you have to save all of them? Why do you have to keep track if you only are interested in the minimum?
That's a good point. So is that what your one is doing?
I think so. So mine just finds the minimum of all of them at the beginning and then just loops over it. Or like, it's not really a loop anymore, but
I guess I can replace this minimum with the mean. Oh no. Okay, if it's actually the same thing, then we can just forget about that.
I think so, yeah.
Okay, so
if you comment mine in, let's run our own test cases and see whether it makes any sense.
Okay, maybe you want to complete your code first, this one?
So it's basically like that.
But you're beginning from the smallest I. Why would you begin from the smallest I?
It's not beginning. It's actually not a loop anymore.
Okay. Maybe test it.
Why is smallest I?
Smallest I is an integer, right? It's not it's not a number. So for I in that, I don't know what that's meant to do.
It's basically just I equals smallest I.
Yeah. Okay.
Just to.
But I think you need to do it like this, right?
I think.
Does that actually work?
Yeah, it works.
No, that's. I think it's a different thing, because you look for the position and you look for the smallest one, but that doesn't necessarily give you the longest string. It just says that this letter is a lot earlier, but you could start looking earlier, but not get the thing, right?
Like the thought was, if I found the A,
yeah,
and then the A here, it's always the best to choose the A. And if I find a Z in the end, it's always best to choose the Z because it's the earliest position here.
Yeah, but what if your A, B, C already matches a bunch of stuff.
Oh, this is the... Oh, okay. Yeah, no, I see where I'm wrong. Because I'm not using... Okay, no. I just felt like...
Okay, let's go back to my one. Go back to my one.
Yeah.
So I build up an array, and all I'm doing is keeping track of. So every time I compute a new position, I keep track of where I am to see if it's, well, to see if I'm after the smallest of the previous ones, then I don't have to do it anymore because the previous test case already covered it. Not sure if this is true, but maybe it's true. I don't know. Is it true? Maybe it's not true.
I'm
I don't
not
know.
too sure about that.
Yeah, actually, I'm not sure if this is true. Maybe it's wrong as well.
I think...
Okay, maybe what if we try on our test cases to see if it actually passes?
Is it ready, your solution? Because it still has some kind of error here.
What's the error?
Find first pos C. That should be I, right?
SI. Oh, that should be I. Yeah. That should be I. I minus 1. That one. Maybe it's yeah. Okay, maybe this is not correct. Maybe this is not correct. No. It sounds like it could be correct. Nothing. No, you don't need to do that because it's already done after.
Yeah, but we have pos might be nothing, and then we can't fill it into our...
Okay, so we just have to move this up then.
Yeah.
Okay. Then I can't initialize at 0. I need to initialize something bigger. It's only 5,000 of them, so it's not that big a deal, I guess.
Okay, that's completely doing something weird.
Completely wrong?
Yeah.
Okay. Position equals to find this. Oh. My position has to be P2 plus that, right? Actually, it doesn't matter. I don't think it matters.
Yeah, because the P2 doesn't change anyway. I'm still not totally convinced.
Okay. Yeah, this is a... I'm trying to think through this one. If I am... Well, let's look at the test case I came up with. Right, so if I'm A, I already know that I'm here. And then once I finish computing the letter A, I move to the second letter, which is B. I realize that B is here, which means that it's after A. What that means is when I computed the longest length for A, I would have considered B.
Yes.
So therefore, I don't need to look at B. That's my whole idea.
Yeah.
Yeah. All right. So So is the thing? I mean, it's a syntax not even correct, or it's giving the wrong results in the. Oh, because we commented out max length. I turn it back on.
No, you have it. You have it down here.
Oh, I have it down there. So yeah, that's not right. Okay, so max length 0.
And it computes something very high, which is
something
weird.
very high.
Yeah, it computes 299 instead of 30. And it's slow. But I think your minimum is slow because it's copying this over and stuff like that. But yeah, let's check.
So I have to so I have to compute this guy. If I compute this guy, why don't I don't even need to keep an array. I just keep yeah, so if position is smaller than this guy, then this guy equals to position. Else, right?
Yeah.
That can't be right. It can't be right. That can't be right. That can't be right.
It's not right. And it computes a different result, which is weird, I think.
I think we need to keep the minimum first position where it's effective, not like every single one of them.
So that's so confusing.
I mean, this algorithm seems to pass all the normal test cases. It's already failing test case 1. Damn it.
Oh, no. Oh. Yeah, it should be at least, it should be 300.
But it's missing 1?
No, it's missing 47.
That's just weird.
It's not computing something too high, it's computing something too low. Because I changed the test case. That's why it was taking more time as well. Okay, so but the idea seems to be kind of reasonable. I'm not too sure whether we implement it correctly. So if A finds that, the B after that, so we have considered it already. For that, so we check. Oh. Oh no. This. I was thinking about less than or equal, but less than or like equal never really happens in a reasonable way.
Yeah.
How about the easier test cases we had? If some of them is wrong, it might be easier to debug. No, they are all.
I mean, the easier test cases seems to be working for me.
Yeah, I don't think that the dictionary is correct at line 36.
36?
Yeah, I think just because that it's after that we shouldn't save that we can't have any lengths, because that might change the. So now it passes the test case at least.
Okay, so the dictionary could be overriding correct solutions from before, I think. That's good.
I don't think that we need that dictionary anymore, kind of, when this works.
I mean, maybe you could try get rid of the dictionary because it's all right. 1, 2, 3, 4, 5.
Test case 4 again. Yeah. Ah, damn it.
What if we get rid of the dictionary? Would that make things faster? I think just comment out that one. Comment anywhere where the dictionary is used. That's fine. Comment on the end. Comment out that one. I just feel that without a dictionary, it might I don't know. I just feel like the dictionary might speed things up, but I don't know. I guess it can't hurt passing it into it. It knows it doesn't use it, so just compile it away, I think. Yeah, no, got rid of the dictionary, it still doesn't work.
You checked it? It's still
Yeah,
too slow?
I just copy and pasted this code onto my side. It's just still the same. 1, 2, 3, 4, 5, 6, 7. Still the same. Oh, actually, without a dictionary, it fails 9 cases. With the dictionary, it only fails 7. I think it's doing something, because.
Yeah, I was just thinking that it's not that powerful anymore, and we have the has key and stuff like that. But yeah, okay.
I mean, hash key supposedly just computes the hash.
Yeah.
Yeah, and it's 01, so it shouldn't be that bad. So with the dictionary, it's it only fails 7 cases.
The same as before. Oh man, that's so bad.
But without it fails 9. Man, I thought we found all the optimizations.
So this should drastically decrease the number of recursive calls, right? But for
I mean, theoretically, I don't see why not.
how long is that string? For like for an 800 character string, it's taking 1.6 seconds.
Yeah.
What are we doing wrong? Oh, not wrong, but too slow.
Man. I think I might have gone crazy. I'm thinking about crazy stuff like building an index for where all the letters are, so you can index into them really quickly. But I somehow don't think that's gonna help. You know?
I'm not too sure whether we can have a faster find first, because I'm not too sure about the view, especially in previous Julia versions, because I think it still allocates some stuff which we don't really need.
I mean, the find first, it's meant to be pretty quick, right? I mean, it's like if it finds it, it terminates. If it doesn't find it, it keeps on going.
Yeah, but I think so. If you have I don't know. Okay. Well, it's taking 500 nanoseconds for length of, what did I have? 300. And it allocates some memory and stuff like that.
Right.
So I was thinking about, I'm not sure whether it, like I would say if we fail, it's probably because we are still not have optimized like the general runtime and not the specific one. But I'm not too sure about that.
Okay. I mean, it's worth trying. I don't know what's.
What do we normally return? D minus start plus 1, probably.
If you're doing this, I suggest you just return D. Then you know D is the position. But I don't like the idea of return nothing. Is it going to cause?
Yeah, but it's much faster than the other one.
Okay.
It's like 22 nanoseconds instead of 500.
Okay. Maybe that will do it.
But is return D? We normally.
I'd say return D because then you don't, in the line 46, you can just do pause,
Okay.
Like that.
Okay.
+1.
I was
+1.
thinking that's. Oh yeah, +1. Okay, but that's wrong.
But is nothing comparison expensive?
Oh yeah. No, I think that's because I think find first actually it also returns nothing normally. I think there's a reason.
Okay.
It shouldn't be slower than.
All right. Okay. Then I think if you return D, that's fine. Yeah.
All right. I have to go in like 2 minutes.
All right. Let's one last try. If it doesn't go through, then call it a day.
Yeah.
Yeah.
Okay. It's not really faster. But,
Not really.
Have you copied it already?
Hey?
Are you trying it out on HackerRank already, or?
No. I'm just gonna watch it on your screen because okay. This could be one of those really tough ones where I can see it. Not happening.
Yeah. But I'm doing something totally wrong. Or not the most efficient.
I have a feeling that it's gonna be a algorithm improvement.
Yeah.
I'm not.
Yeah.
I mean, theoretically, the dictionary also can be improved because currently it's looking for a hash key and then return the value. There's a function to let you look up and then return the value as well. In the one pass. So.
Oh, you mean with
the hash key?
Get like default with a default value if it doesn't.
Yeah.
Yeah, I think it's just get.
Is it? Okay. Yeah, that could be improved, but all right. If you gotta go.
Yeah.
When did get the default value get end up in there? Oh, so it just I can just do it here. I don't need to check if it's hash key. Just go L equals to get dict. Yeah, like that. And the default value is -1 or something.
Yeah, but for and then you check again. I'm not sure whether. Oh, okay, because you don't hash it twice. You mean?
Yeah.
Yeah. Okay. See what you mean. Okay. Yeah. All right. I gotta go.
All right. Okay. See you next time.
Kick you out from the live share.
All right.
All right. Yeah, maybe we do another stream and try to tackle it. I have to go now.
All right. See you.